Hello, everyone. This is going to be a video that's going to be part of a short little series about Arduino and kind of that portion of the programming digital media class. The way I'm going to set this up is I'm going to be recording several videos. So today I'm hoping to get the one that you're watching right this second and the one on analog Arduino done. I'm going to be doing them kind of in separate portions. So I'll talk about the code part in one video, and then uh, the circuit building part in a separate video, and then through the magic of video editing, just stick them together into one longer thing. So you'll have, some separate ones and then longer ones all in the playlist together to check out. So with that being said, let's just kind of hop right into it. Uh, so before we do anything, this will be the code-based video. So if you don't have the code editor downloaded, you're going to want that. You can get that from the main Arduino site, arduino.cc, and under software, you can find the Arduino IDE right here. You can download it for your appropriate device. There's other versions as well, so you can explore it if you want. You can get a beta version of um, the version 2.0. It's fine. It works okay, but the version 1.8.19 is a little more stable than the others. So basically, just find this one. This gets updated periodically as well. I don't think this one has been updated as recently. So again, stick with the version 1.8 point whatever to start with, but if you want to explore some of these other ones, you can. There's various older versions and other formats and whatnot, but go ahead and download and get that installed. If for whatever reason you can't get this installed, there is a browser-based web editor right here, and you can go into that. You have to make an account and log in. Mine was still logged in from before, but you can do all the things in the downloaded app in the web browser. But when we get to the final section of this video will have this series will have three big sections. There's going to be reasons why this can become a bit of a pain to work with. So I recommend working with the downloaded app. So once you've done that, we can get it open. I don't have it on the bottom here. Arduino. And it will open up. It's a pretty small, simple software. I forgot I made my font bigger for the purpose of a video. So let's just, so I'm going to open up the programming digital media page. Oop, that's P5. I wanted that one. There we go. And I'm going to head into Arduino while the software is getting up and going. So just a few quick things. There are some general differences between working in P5 and with Arduino. The most common ones are that all of your lines have to end with the semicolons. Again, anytime you give the computer a command, it needs to end with this semicolon. Otherwise, the code will not work. And there's no way around that. You just have to do it or it will not work. So stress that to your students. They will get error messages and the code will not run. Generally speaking, you're going to type void instead of function. There are points where, that won't be the case, but those are a lot less common if you just kind of stick to the main portion of what we do here. We call it loop instead of draw. They do the same thing, basically. And then variable types is the other kind of big one. So in P5 and JavaScript, what we do is just say let, and that makes the variable, and we can make it any type of variable we want. In Arduino, that's not the case. We have to specify what kind of variable we're going to work with. So int is for integer numbers, floats are for floating points, so they have decimal points after them. Constants are read only, so you can make a constant and it doesn't change while the code runs. Char is characters, what it's short for is for strings. There's also bool for booleans, stuff like that. So again, you have to specify what kind of variable you want to work with. Alright. Let's see. Other than here, these are the main functions we're going to be using as part of the base Arduino stuff. So whenever we use a digital pin, we have to specify that it's an input or an output. We can write and read digital data, and we can also write and read analog data. Again, that's kind of the basicness of it. So real quick, I'm going to pull up the Arduino code editor here. I have some stuff to update. So if that message pops up, you can click on it, and it'll show you stuff to update. So I've got a handful here. So you can just click update all of these. You don't necessarily have to. It depends on what you have installed. I have a fair bit of these libraries installed, so I'm almost always getting some kind of something needs to be updated message. But anyway, here is the web editor. Basically, by default, it'll name it sketch underscore whatever the date is, and then a letter. And then if you've made a bunch of sketches in within 24 hours, that letter just works its way through the alphabet. So whenever you make something, in order to send it to your board, you have to save it, and there's certain ways it has to save in a folder and all that. But we start off just with the basic setup and loop, just like P5. This is the default starting code. So basically, we're going to work with something really simple here, and we're just going to make some digital outputs just to begin with, something nice and easy. We're just going to say const int. So we're saying that it's an integer variable, but it's also a constant. We're giving it two names here, like I mentioned. So this will not change while the code runs. And we'll say LED pin equals 13. All right, so basically in our circuit that you'll see in just a second, we're going to connect this to pin 13. It's pretty simple. That's going to be a digital pin, so we have to go into our setup function here and say pin mode, and we'll say LED pin, and that will be an output right there. So again, for every digital pin that we have to use, and on the Arduino Uno, they should be labeled digital pins, but I'm going to skip past the setup. I'm going to hop right into the digital stuff. So this is a page here that talks about the digital pins and things like that, and we're actually going to be building this example through the code, so I won't look at it here, but that's not what I wanted. I wanted setup. Yeah, parts of the Arduino. So your Arduino, assuming you're using an Arduino Uno, which is the most common one to use here, there's a bunch of stuff on the board. This is an Arduino unit. It's not made by the company, but it's all right here. There's a bunch of different stuff, and I've kind of labeled the most important things for you to have. So there's an LED, that's built into the Arduino here. There's also a power indicator, a kind of restart button. So if you press this, the Arduino just stops and restarts and runs the code that you've sent to it. You can connect it to the USB, and that's how we get the data sent to it normally, as well as power supply. But you can also connect it through this barrel pin connector here to like a battery or something if you want. We have analog pins, digital pins, and then the power, specifically the section on power distribution. So those are all kind of the big main things. So any of these digital pins, they can either send electricity in or they can receive it or send it out. That's the main idea here. Digital, the short version of it is it's two states. It's digital two states. It's either on or off, in or out. That's it. There's no other options. It's either 100% or nothing. It's on or off. I can't. I'm basically just kind of repeating myself at that point, but that's how these pins up here function. There'll be another video later on. I think I said earlier there's 3 sections to this. I misspoke. There's going to be 4. But with these little squiggly lines here are indicating something that'll come up in video 3, and then we'll talk about the last video a bit later. But that's all there. The analog pins down here are only input pins. They cannot output stuff. So again, we're going to be focusing on these digital pins, and they can either send or receive. So we have to say pin mode and tell it that we're going to either output or input electricity. And we'll work with the input a little bit later. So I've got that there. Inside of the loop, we're just going to say digital write, which means we're going to send and you're going to output a digital signal through a pin. And we just have to say what pin we want. So the LED pin, we're going to say we're going to write that to high. There we go. And then I'm just going to have it wait a little bit. A delay pauses the loop. And let's just say, I'll keep it the same as the other example at 1,000 milliseconds. So that's going to pause the loop by 1 second. I'm then going to copy and paste everything, and we're going to write the value low to the LED pin. So what we'll see when we send this to the board is it's going to turn on the LED. And we're going to do that. I didn't explain, but basically we're going to turn on and off, and on and off. And that will happen forever. So what you're going to want to do is plug in your Arduino Uno to the computer. We're going to send or flash this code to the Arduino. In order to do that, once you've connected it, you're going to want to go to Tools, and you're going to want to make sure that your correct board is selected, so you can go and find it here. Usually it'll be Uno, but here's the other Arduino boards. And if you have things that aren't Arduino, you can still use them here. I've got a whole bunch installed as part of a library for some other stuff that I do with non-Arduino based boards, but they use the same manager here. But then under port, once you've connected it, you should see a port, and it'll be labeled here with, it'll say Arduino Uno. As I'm recording just the code video, I don't have that right this second plugged in, but in just a moment we will. But anyways, you'll see that there. If you're on a Mac and not a Windows device, it won't say COM6. It'll say, it has some big long name, but it'll still say in like parentheses afterwards, Arduino Uno, and that's the one you want to select. We're going to get an error if I try to upload mine, because I don't actually have it connected. Basically, it just will say it can't find the board it's looking for on the port you specified. So again, you want to make sure it's looking for the correct board on the correct port, and you'll see that kind of at the bottom of the screen. Let me just hide my face. There we go. So you'll see at the bottom right of the screen where my face was, just above my system clock, it'll say it's looking for an Arduino Uno board on port COM6. So if there's not an Arduino Uno board plugged into COM port 6, then you just won't see the Arduino. You're going to get an error. So make sure that all matches up. And then we have a few options up here. So there's the verify, which just does, hey, does this work? And you have to save it first if you haven't. So I'm just going to save it at the default bit. It's going to compile the sketch. And if there are no errors, which there shouldn't be on this one, it gives you some information about it. Basically just tells you how much it does and how much, memory you have left on the Arduino board. There's not a lot of memory. 32 kilobytes. Yeah, 32K. So, that's not a ton of others. So just be aware of that. You can't have these massive codes. But anyways, once you've done that, you could upload, and it will verify it, and it will send it to the board. So, to hop right in with this one, I have got on the screen what you should have hopefully just seen. And this is setting up some LED stuff, some basic workings. This is actually, no, this is the wrong one. Actually, no, we'll start with this in its basic form. So in the video, we basically built our own version of the blink code, which I have here. It's a preset on Arduino, and basically it just loads in the built-in LED, and then it just blinks it on and off. This particular variable is a bit more useful if you specifically want the built-in LED, just because the pin it's on may be different from Arduino to Arduino, but we can change that around. I'm just going to make it match the pin we're using in the other example. It's going to have the same effect. So then I've also got on my desk here my Arduino. You can tell it's connected to power because the LED labeled on is on, and everything else is going. So if I can, I've got a long cable on here so it reaches my USB port, but we can do that so hopefully it stops dragging it down. So what I'm going to do is, this won't require any extra components. So I'm going to go under Tools, and I'm going to make sure, yes, it's an Arduino Uno. That's correct right there. And then under Port, you'll see the one here. I'm currently plugged into port 3 where it says Arduino Uno, so if you click on that, and you'll see at the bottom of the screen where my face usually appears in my videos, it is now telling us that that is correct. So we can upload this sketch. We didn't get any errors. It's now, and we should see, there we go. Hopefully the glare isn't too bad according to what I see on my screen. But you can see that built-in LED, which is attached to pin number 13 on an Arduino Uno, is now blinking on and off. I'll go a little closer into this. I've got my Arduino over here. The cable is kind of long and heavy, so it's going down to my desktop down below, and it's kind of pulling everything down bit by bit. I've got a breadboard, which we'll be using to build our circuits. This is a very useful tool that does not require any soldering for circuit building, so it's a handy tool to have. I have some various lengths of jumper wires that we're going to be using as the wires for the circuit. And then over here on my desk, I've got a bunch of different Arduino components. There's way more in here than we'll actually need for the course, but there, it is there, and there are options. A lot of what we're going to be focusing on is going to be built out of the LEDs, or light emitting diodes. Let me pull up a really clear one so we can see it. So basically, a diode is an electrical component that only allows electricity to flow in one direction. I've got one right here that is pretty clear. Let me see if I can focus on that a little bit better. I didn't notice a difference. But if you were to look into it, come on. If I go over the black background. There we go. You can kind of see that there are those two metal points. And this particular diode is a light emitting diode, or LED is probably more common with it. So the electricity will always flow from the positive end, which is the longer wire, through the main component here and out towards ground in this shorter wire. And basically the electricity just kind of moving between these two pieces of metal right here. Can I get any closer and it stay in focus? Kind of. And as it does that, it loses a lot of energy in the electrical system, and that is what we see output as light. LEDs come in many shapes and colors. I've got a lot of different ones in here. I'm going to go with the red ones because the blue ones really blow up on video and are a pain in the butt to see. So let's go with the red ones. So to stick these into our breadboard, you'll notice that there are tons of holes in here. And these holes are designed to put the various components in their leads, is what they're called, into them. They're used to kind of distribute power both vertically and horizontally through the system. So the vertical aspects are these on the side here. You notice they got these big lines. So when you hook it up properly, this will be all the positive voltage here and all the negative voltage on the right side as well. In the middle, though, this is where everything is horizontal. So you'll notice that for down here, there's row 30, and there's 5 sets right there, and we're going on. So anything you plug into on one row, it's all gonna, anything else plugged in on that row will also get the same electricity going from that source. I think that'll be a little more clearer once we actually start building. So I'm actually just gonna hop into it, and I think you'll see as we go along. So I've got my LED here, and I'm gonna plug it in. I'm just gonna go right here, so there's plenty of room before. I mentioned that, again, horizontally, they all share electricity, so you want to put this between 2 different numbered rows. For the case of the LED, again, direction is important. If your students are doing this properly, if there's no, like if the LED is in the wrong way, there's not really a risk of it breaking or anyone getting hurt. It just won't turn on. But if they're messing around and not doing things properly, we run into issues. As you can see there, my LED did not want to go in, and it kind of bent up the leads. That is okay. Some of these require a little bit of a little, little oomph to get it in there. So we'll connect that. I'm gonna grab some wires here, and for now, I'm going to just connect over to my Arduino. There's the power section right here. It's usually labeled power. So I'm going to connect my red wire here to 5 volts. I'm going to go with this green one here for ground. Green will work, brown will work. I mean, the wires are all the same on the inside, but generally speaking, you have your red for the positive power and black or sometimes green. I've seen white a few times too, actually, but those different ones for ground. So you can just get it in there. This is a not very often used one, and I'm also going one-handed, so that's fun. Get into that board. Again, these do not always want to go in, so I'm gonna come back to that one. Negative, get in there. It doesn't really matter which ones they go into, because it'll move the electricity through the whole system for right now, but it's really just kind of annoying when they don't want to go into the hole. So I'm going to set this to the side, and I'll keep talking while I get all of these bits into the hole here, because it really just does not want to go in. Okay, well, it's not pretty, but it is in there. So now we've got this little vertical row here is all energized. One thing that's very handy to do with your breadboards is to add another little wire to connect the 2 sides of the board. So I'm going to go from positive to positive. There we go. And I'm going to grab a similar length wire, and we're going to go from negative into negative if it gets in there. One moment. It's being a real pain today. This breadboard. Just grab the first one I saw, and some of them inside is basically just a bunch of little metal clips, and sometimes they things go in nicely. Other times it requires just a little bit of oomph to get it in there. So hopefully I'm not doing that a whole bunch, because that just makes for a boring video. Okay, so I've got all of those components in, and the reason I've done this is because, kind of illustrated by this big groove here, is that the little metal clips inside that let the electricity run in the horizontal and vertical patterns don't go all the way through. They stop in the middle. So by doing this, we can get the power and ground from the Arduino sent to both sides of the board very easily. So let's just do some stuff with it now. So I've got right here some 220 ohm resistors. We can have a variety of resistors for what we're doing here. Sometimes we may want bigger ones or smaller ones, but basically the more resistance that the resistor has, the less electricity can flow through it, the system. So I usually find somewhere between 200 and 300, give or take, ohms is generally pretty decent for an LED. So we'll use this a lot. Okay, the long lead is facing me. So what we can do is wire this up just to turn on. So we have to have a resistor of some kind in this system, or else things will start to short circuit. Basically, if you and your students are doing this properly, you won't hurt yourself or anyone, but with any electricity not coming from the Arduino and the computer, this can potentially be dangerous. So again, I want to stress that. So I like to plug my resistors going into ground. So I'm going to take one end there and the other in the same row as the short lead of the LED. So we get this. And then lastly, we can just connect the long lead of the LED. So I'm going to plug into that same row. And then this will go into power here. Get in. It's in enough. It's in there enough to turn on. So again, the way that this circuit is working is that we are getting 5 volts from the Arduino, and more specifically the USB connection in the computer, but we're getting it from there. It's going into the breadboard. It's then coming out of there into the LED. It's going through the LED and then through the resistor back into ground, which is the same ground connected to everything else. And that's what's happening right there. Again, if we stuck the LED in backwards, nothing would happen. If we didn't have if we had a much smaller resistor, would notice the light would be brighter, and if it was a much larger resistor, the light would be a lot dimmer. So I find about 220 or so is a decent one for working with the with LEDs. There's math involved for working this out, but I've seen them, that might be a little on the lower end. I've seen 270 is pretty common, 320 is used. Again, somewhere in that ballpark, and you should be fine, and you won't have anything popping on you. Okay, so that's the first bit there. But if you remember from the code, we have... there it is. We have this blinking LED, and we want to achieve that here with this one. So this is what I'm going to do. Instead of connecting the LED to the always on power, I'm instead going to take a longer wire and I'm going to plug it into pin 13. You should hopefully remember that from the code. That was what we labeled as the LED pin. So I'm going to plug one end of the wire into that same lead, positive lead of the LED. If I can get it in there we are. And then I'm going to come around, and over here on the digital pins, I'm going to find 13, and I'm going to stick it into that hole. I'm going to get that in there while looking through my phone. There we are. So now what we should see is that whenever this LED that's built in
turns on, the one in our circuit should also be turning on. I can see it now, you can't. But that's what we can expect to see because, again, this built-in LED on the board is connected to pin 13. This may be different if you're not using the Arduino Uno, but all of the built-in LEDs have a pin that they're attached to. So if we move over here, we should see that now this light is blinking. And if we were to put them kind of both in the same shot, you can see that they are both blinking together. The reason this is working is if you look at the code, we are just saying that every loop we are going to turn on and send electricity to pin 13. We're going to wait for 1,000 milliseconds, and then we are going to turn off the electricity and then go from there. That's pretty much all it is. Pretty straightforward. This is the blinking example.
What I want to do next is now add in a digital input. So the digital input, as we'll see, are any digital signal that is being received by the Arduino. So it is sending that data, or that electricity in, and the Arduino is responding to, is there electricity, yes or no, on a certain pin. So to do that, I think a button or a switch is pretty straightforward. So let's work with a button first. So const int button pin is going to equal, and I'm just going to arbitrarily pick 7 this time. For right now, it doesn't necessarily matter, but later on it will matter what pins we are picking. Because pins 0 and 1 are used for sending and receiving data as well, you can run into issues putting things on digital pins 0 and 1, so I recommend avoiding it if possible. Okay. Next, I'm going to hop over to here. So I've made the button pin, and we'll say pin mode. And we'll say that the button pin is going to be an input in all caps. So we have that right there. And so we can just write around this. And basically, we're just going to say that if the button pin is written, then we will write the code. So I'm going to get rid of that delay. And we actually need to say int button state equals 0. So basically, we're going to monitor the button state, and I'll keep it consistent and make it button state. And I'm just giving it a default value of it's off. There's no electricity. So what we can do here is in the loop, we can just say button state gets assigned digital read. And specifically, we're going to read from the button pin. So every time the loop loops, we're going to store inside of the button state variable whatever the state of the pin is. So from the button pin, which in our case is pin number 7, we can swap, again, we can swap around what these pins are just by changing the variable value. But basically, we're going to read that value and, say there's either yes or no electricity, and it's going to get stored in that variable. So what we can do is then say if, and we'll add that, add it in here. So we'll say if something is true, we will write that LED pin to high. Else, we will do something else, and that else will be writing it to low. So that should all be there. So what that if will be is if the button state equals true, then we will write that to high, else we will write it to low. So in Arduino, I find that generally it works best with the 2 equal signs. I tend to use 3 in P5. There are reasons where you may or may not want, where you need the 3 versus the 2. It's basically, it's either if it's equal to or if it's strictly equal to is the difference. Um, and basically that just gets into more things like data types and stuff like that. But basically, the short version is I find Arduino works best with 2 equal signs here in the conditional statement. Sometimes you may want 3. It's a more on a case-by-case basis, but for what we're doing and what the students do, 2 tends to work best in the conditional statements. So what we'll just say is we're going to, every time the loop runs, we're going to look at the pin and see what it is, and then if there is electricity flowing through the circuit, we will turn on that LED. Otherwise, we're just going to keep it off. So we're going to send that to the board. It's going to do all of its thing. I'm not going to do it because I don't have one plugged in while I record this. But if we verify the code, we got no issues. Again, if there's problems, this will all turn orange and it'll tell you there's problems. But that'll send there. So I'm going to transition again to the video of me working on the desk with all the stuff. But you'll see that, again, we'll wire up a button. And as we press the button, everything will work properly.
This other one is the one we kind of wrapped up with when I recorded the previous video, and this is going to be responding to a button input here. So I'm going to go into my box of stuff and grab a button. I'm going to use this one, little tiny one specifically. I like these red ones, but I haven't used them before, so I don't want to spend part of the video figuring that out. So I'm going to connect it, and I find these work best if you plug them in kind of over this little gap. They're pretty well sized for that. So we're going to have that right there. To wire this up, it's going to be a little bit different. I do want to take this chance to point out that I do have a tutorial for this all written out in the online textbook for my class here. So if you were to head into the lesson adding buttons and switches in the Arduino unit, you'll come up on this page. And then if we scroll through it, there's buttons and switches, and there's diagrams and all that kind of thing, and that should look kind of familiar. But we're going to be doing this, more or less. Actually, this is just a switch that interrupts the flow of electricity. It's not. It's another way to make a power switch, but we're going to be doing it slightly differently with not that. This walkthrough. So this is a step-by-step walkthrough of what we're going to do. So you stick your button. We're going to connect all the power and ground. We've done a lot of this already, but this is where we're going to start doing new bits, and this will walk you through how you can wire up a button in order to work properly. I'm just going to leave this here for a moment while I get my wires ready to go. So I've got those, and I need my 10K ohm. So you'll notice that resistor in the diagram looks a little different than the one we've done before. I'm not going to go in and deep dive into all the resistors, but just know that the different color bands on them tell you what the resistance is. I've just pulled out of the bag here the same one we have up there. That is a 10,000 ohm resistor. That's a fair bit more than the 220 ohms we see here with the LED. And I'll just hold them next to each other. And you can see that the bands are different colors in different orders. So that's how you can work that out. So in order to connect this up, what we're going to do is we're going to connect one side of the button to power, which I'm going to do just like this, to power. Boom. And then on that same side, we're going to connect this 10,000 ohm resistor to ground. I'm just going to plug it in like that. And what this will do is, because there's a lot of resistance on there, whenever we press the the electricity is not going to flow to ground. It's going to flow through the basically we'll be able to tell that the sensor is happening whenever we press the button. Because there's this big resistor on the grounding. So what we can do next is grab a longer wire. I'll make it I'll keep it a yellow one just because I have a lot of yellow ones. And looking at the button, we're going to go starting from that positive end. We're going to go diagonally through the button, and we're going to just plug this in on that same row as the little feet. And this is what we're going to plug into the Arduino. Again, if you kind of look here at the diagram, again, we're going from the positive end to the button, and then on the other leg on that same side, we're going through the resistor to ground, and then up here, we're going to go straight to whatever pin. If we look at the code, we're going to be connecting this to pin number 7. So I'm going to go find 7, and I'm going to be plugging this in right there. If I can get it in. The wire's a little bent. Get in there. There we go. Didn't think when I recorded this, the hardest part would be getting the little things in there. So again, just as a quick little refresher, because I've been recording this for a few minutes now, is basically we are going to set the LED pin to an output and the button pin to an input. It's going to be doing the same thing. We're just going to turn on and off the LED. And to do that, we're just going to see whether or not the button is pressed. And if it is, we're going to turn the LED on. If it's not, we're going to turn it off. My Arduino is still plugged into the same port and everything, so that's all good. So I'm just going to hit upload. We didn't get any errors. It's doing all of its thing. It actually stopped doing all of its thing before I could even get the camera down there to look at it. But if I click the button, we should see that turns on. So, yep. So again, I'll show you the circuit next, but as I click this, let me make it in focus, you see that turns on. This button is a little loose here, so there's a little bit of, I'll call it noise, but basically just errant electricity. So if I wiggle that button, you may see that it kind of comes on or not when we're not meaning to. That's just because it's not seated very well into the Arduino. When it's nice and in the hole properly, it's working just fine. So I'll kind of hold this in there with my middle finger, and as I press this, you can see that as long as the button isn't moving and making electricity move in weird places, that it is now functioning as a power switch. Again, there are other ways you can do this, but this is one where the Arduino is detecting whether or not electricity is flowing through the button, and then using that compute that bit of logic there in order to manually turn on and off this LED. So there's that. We can also see this in the code. Actually, not in this one. I got ahead of myself. I recorded a bunch of these codes the other day, and they're kind of all blending in my head. In the next bit of circuit building that we'll be doing, we'll see that when we start playing with the analog signals, because that's a little bit harder to work out the details. In this one, there either is electricity or there isn't, and that's pretty clear how to work with that. So that's pretty straightforward. Again, if your buttons are a bit wiggly, you may get electricity doing weird things. You may have different sized buttons. We can try this other button that I've never used before. I think that's actually the same size spacings, but it should ideally work the same, but this fits into the hole a little bit better. Yeah, it works the same. And this one, it sits in the holes a bit better, so it's not, moving. And that's the basis of the digital inputs and outputs, having some kind of signal that is detecting is there electricity, and then your Arduino responding to that. The codes are very, very simple. The circuits, I wouldn't call them very, very simple, but they're not super complex. But by combining these, we can get very interesting results. So in terms of your components, most of them are actually analog components and what generally comes with your kit, but all of the LEDs we can work with. You'll have buttons of various kinds. You may also have some switches of various kinds that, again, you could utilize and just have something happen whenever you flip the switch. We'll see more of this stuff in the next video, so be prepared for that. But again, we'll be mainly focusing on LEDs as a kind of core piece to this unit.
So that's going to be the end of this video. Again, I recommend checking out these sections here of the Arduino. I have one that's, again, a bit more about some of the basic concepts of electricity, but then working with the digital inputs and outputs. So it's, again, this page here. Again, here's that blink example that comes from the Arduino. I kind of break that down. And then we kind of go through working with the LEDs and how that works and how we're building those circuits. Again, we tend to focus on LEDs in order to get this done, because it's a very clear example of, hey, something has happened, something is responding. We can see very clearly that the circuit has gone through and has begun to work. So again, check that out. There's some examples, some circuits you can build, just, very simple. Does it work? Does it blink? Things like that. And then talk about the circuit diagrams as well. But then what we just talked about, adding the buttons and switches to that system, that's kind of a bit what I talk about, but in a little more detail here. So definitely check that out. And I go in and I actually go step by step. This is the circuit I build in the video. So again, this is kind of some step-by-step process, and apparently that's dead, or just didn't load this time, but talks about switches as well, and there's some video examples and some code examples if you would rather see a switch instead of an LED, or a button, I should say. And that's it. There's the code stuff I just talked about. And basically, again, yeah, if there's all that, I say hi here instead of true, that works. So I could go in and say if it's hi. Either one should work for this, but basically it's just if it's something, we're gonna write it to high, otherwise it'll be low. And you can see this kind of code here as well, and some step-by-step bits with pictures to follow. And that should be all of the steps. Here's a diagram version of what we just did, and some possible applications and things like that. What I've got to wrap it out here is, again, some other digital sensors. So some sensors are digital versus analog, so you may or may not want to focus on those, but buttons and switches, I think, are the most straightforward things that students will be familiar with and find a good use for. So I recommend sticking to buttons and switches. And this all leads into being able to control stuff with multiple buttons and switches. You're basically having different LEDs that you can trigger at the same time with that, and I give them some starting code. And I think that's just about it. So I'm going to wrap this one up, and I will see you all hopefully very shortly talking about analog code and analog circuits. So that's going to be it for me, and I will see you all the next time that I see you. Bye.